When setting up temporary power for an event at the fairground, it's crucial to understand how to safely connect your equipment to the existing power supply. Assuming the fairground provides a 240-volt single-phase power source with a 30-amp 3-wire 240-volt receptacle, here's how to proceed. Firstly, you should treat the 30-amp 3-wire 240-volt receptacle as a new electrical service for your distribution panel. This means you'll run your two hot conductors, often labeled LORN and L2, directly from the receptacle to your main distribution panel. Secondly, and this is very important, do not bond the neutral and ground conductors together in your distribution panel. The Fairgrounds electrical system is likely ungrounded, which means it does not have a dedicated neutral conductor at the receptacle. Bonding the neutral and ground in this situation will create a ground fault, which will cause the circuit breakers to trip, interrupting power. Thirdly, you must install a ground rod at your main distribution panel. Driving a ground rod provides a dedicated and reliable path to ground for your equipment and any connected loads. This ground rod serves as the primary grounding electrode for your temporary electrical system, ensuring that any fault currents have a safe path to earth. So what happens if you lose your ground connection? This is a critical safety concern. Firstly, the overcurrent protection in your distribution panel may fail to operate correctly. Circuit breakers rely on a low impedance ground path to quickly trip in the event of a fault. Without a proper ground, the fault current may be insufficient to trip the breaker, leaving your equipment and personnel at risk. Secondly, ground faults would not trip the circuit breakers. If a fault occurs, such as a wire shorting to the metal chassis of a piece of equipment, the absence of a ground connection means there is no path for the fault current to flow back to the source and trip the breaker. This can lead to dangerous voltage on the equipment, posing a shock hazard. Thirdly, backfeeding can occur. Without a proper ground, current could flow from the 120-volt loads back through the 240-volt equipment, potentially creating hazardous voltages on the 240-volt circuits. This situation could damage equipment and create a significant electrical shock hazard. As an alternative solution, if you're concerned about the reliability of the ground connection from the Fairgrounds receptacle, consider renting a portable generator with a properly grounded output. A generator provides a self-contained and grounded power source, ensuring a stable and safe electrical system for your event. To summarize the key steps for safe power hookup at the fairground: firstly, treat the 30-amp 3-wire 240-volt receptacle as a new electrical service. Secondly, do not bond the neutral and ground conductors together in your distribution panel. Thirdly, install a ground rod at your main distribution panel to provide a dedicated ground path. Fourthly, continuously monitor the ground connection throughout the event and address any issues promptly. Fifthly, consider using a portable generator with a grounded output as a backup solution to ensure a reliable and safe power supply. To elaborate on grounding in more detail, it's important to understand the fundamental principles. Grounding provides a low impedance path for fault currents to return to the source, allowing overcurrent protection devices, like circuit breakers, to quickly interrupt the circuits and prevent electrical hazards. Without a proper ground, fault currents may find unintended paths through equipment, people, or structures, leading to electric shock, fire, or equipment damage. The ground rod should be installed according to the National Electrical Code (NEC) requirements. Typically, this involves driving an 8-foot-long ground rod vertically into the earth until it is fully buried. The ground rod should be made of a conductive material, such as copper or copper-clad steel, and should be sized appropriately for the expected fault current levels. The connection between the ground rod and the grounding electrode conductor must be made with a listed and approved connector. The grounding electrode conductor should be sized according to NEC Table 250.66, based on the size of the service entrance conductors. It is also important to protect the grounding electrode conductor from physical damage. This can be achieved by running the conductor through a conduit or other protective raceway. In addition to the ground rod, it may also be necessary to bond other metallic components, such as metal water pipes or building steel, to the grounding electrode system. This ensures that all conductive parts are at the same potential, minimizing the risk of electric shock. Bonding should be performed in accordance with the NEC section 250.90. When using a portable generator, it is essential to ensure that the generator is properly grounded. Most portable generators have a grounding terminal on the frame, which should be connected to a ground rod or other suitable grounding electrode. If the generator is supplying power to equipment through cord and plug connections, the equipment grounding conductors in the cords and plugs will provide a ground path back to the generator. However, it is still recommended to ground the generator frame for added safety. Now let's discuss overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow. These devices interrupt the circuit when the current exceeds a predetermined level, preventing overheating, insulation damage, and potential fires. Circuit breakers are typically used in distribution panels to protect branch circuits. They are designed to trip automatically when an overcurrent condition occurs. Circuit breakers can be reset after they trip, allowing the circuit to be restored. Fuses, on the other hand, are one-time use devices that must be replaced after they blow. Fuses are typically used in equipment and appliances to protect individual components. The size of the circuit breakers or fuses used in a circuit should be carefully selected based on the ampacity of the conductors and the load requirements of the equipment. The NEC provides guidelines for selecting the appropriate overcurrent protection for various types of circuits and equipment. It is important to ensure that the overcurrent protection devices are properly sized and installed to provide adequate protection. If the overcurrent protection is too small, it may trip unnecessarily, causing nuisance outages. If the overcurrent protection is too large, it may not trip in time to prevent damage to the circuit or equipment. When working with electricity, it is essential to follow safe work practices to prevent electrical shock and other hazards. Firstly, always de-energize circuits before working on them. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. Secondly, wear appropriate personal protective equipment, PPE, such as insulated gloves and safety glasses. Insulated gloves protect against electric shock, while safety glasses protect against arc flash. Thirdly, never work alone. Always have someone nearby who can assist you in case of an emergency. Fourthly, be aware of your surroundings. Avoid working in wet or damp conditions and keep your work area clean and free of obstructions. Fifthly, follow the NEC and other applicable electrical codes. These codes provide detailed guidelines for safe electrical installations and practices. Finally, if you are not qualified to perform electrical work, hire a licensed electrician. Electrical work can be dangerous, and it is best left to the professionals. To delve a bit deeper into the NEC, the National Electrical Code is a comprehensive set of standards and guidelines for safe electrical installations. It is updated every 3 years by the National Fire Protection Association (NFPA) and is widely adopted by jurisdictions throughout the United States. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, bonding, and equipment installation. It is essential for electricians, engineers, and other electrical professionals to be familiar with the NEC. Some key sections of the NEC that are relevant to temporary power installations include Article 305, which covers temporary electrical power and lighting installations. Article 250, which covers grounding and bonding. Article 400, which covers flexible cords and cables. Article 520, which covers theaters, audience areas of motion picture and television studios, and similar locations. The NEC provides detailed requirements for the installation of temporary wiring, including the type of conductors, the methods of support, and the overcurrent protection. It also specifies the requirements for grounding and bonding of temporary electrical systems. In addition to the NEC, there may be other applicable electrical codes and regulations at the state and local level. It is important to check with the local authorities to determine the specific requirements for temporary power installations in your area. Also consider using a qualified electrician. They can perform load calculations to determine the appropriate size of the distribution panel, conductors, and overcurrent protection devices. Load calculations involve estimating the total amount of power that will be used by all of the equipment and appliances connected to the electrical system. The load calculation should take into account the continuous and non-continuous loads, as well as any demand factors that may be applicable. The NEC provides guidelines for performing load calculations in Article 220. Based on the load calculation, the electrician can select the appropriate size of the distribution panel, conductors, and overcurrent protection devices. It is important to ensure that the electrical system is adequately sized to handle the expected load. An undersized electrical system can lead to overheating, voltage drop, and potential fires. In addition to the technical aspects of temporary power installations, it is also important to consider the administrative requirement. Many jurisdictions require permits for temporary electrical installations. The permit application may need to include a site plan, a load calculation, and a description of the electrical system. The local authorities may also inspect the temporary electrical installation to ensure that it complies with the applicable codes and regulations. It is important to obtain all necessary permits and approvals before starting the temporary electrical installation. Failure to do so can result in fines, delays, and even the shutdown of the event. Finally, always remember that electrical safety is paramount. Take the time to understand the risks involved and follow safe work practices. If you are not qualified to perform electrical work, hire a licensed electrician. Your safety and the safety of others depend on it.